children. Welcome back once again to my maths class. In our video lesson today I'll be going to solve for you the problems in 9.3 exercise. So let's see the problems in the 9.3 exercise. I've noted down the problem. This is the problem 4 in 9.3 exercise. So find the area of the shaded region in the figure where ABCD is a square of the side 10 centimeters and the semicircles are drawn with each side of square as the diameter. So here it is asked area of the shaded region. See the figure here. The shaded part is this. We have to find the area of the shaded region. Given that the side of the square is 10 centimeters. Also, it is mentioned that the semicircles are drawn for the side of the square as diameter. So, this is one semicircle. The diameter of the semicircle is the side of the square. That means it is 10 centimeters. And we can say that the radius is 5 centimeters. Okay. Radius 5 centimeters for the semicircle. So, for this problem, first I'll mention for the unshaded part, I'll keep these parts as 1, 2, 3 and 4. Okay children, see the unshaded part I have mentioned because they are of no different shape like this, isn't it? So I have mentioned 1, 2, 3, 4 so that we can easily solve. Now we'll find out the area of part 1 plus the area of third part. So first I'll find out first and third, next second and fourth. The unshaded part I am finding out. So how will get the area of the first part and the third part? See here. If I take the same diagram, this is a square. These are the two semicircles. So I want this part and this part, the area. So if I find the area of the square and I'll subtract the area of the semicircles, two semicircles, then I'll get the area of first and the third part. So area of the square ABCD minus area of two semicircles. Two semicircles. If I remove these two, we get only this part, this unshaded part. So for that, area of the square is having the side 10 centimeters. So 10 into 10, area of square is side square, 10 into 10 minus area of two semicircles. So 2 first I'll write. What's the area of a semicircle? It's half the circle. So pi r square by 2. So let's cancel this. Here it comes to 100 and here given pi value as 3.14, we have to take 3.14 into r. R is nothing but this side of the square is diameter. Now radius becomes 5 centimeters. So 5 into 5. This comes up to 100 minus 3.14 into 25. This is 100 minus 78.5. It comes to 21.5 centimeter square. This 21.5 is the area of first part and the third part. Those are the unshaded parts. Similarly, we can say the area of the second part and the fourth part. Second and fourth part area is also again equal to 21.5 centimeters because the same region here, this part and this part, we have to remove the semicircles from the area of the square. So that is also 21.4. Overall, the unshaded part, area of the total unshaded part, unshaded region equals to 1, 2, 3, 4. That means 21.5, 21.5. It comes to 43 centimeter square. And see once again, I want the area of the shaded part. So the area of the square minus the area of the unshaded part. If I take these 4 out, you will get simply the area of the shaded part. So here, area of the unshaded part we got. I have to minus it from the area of the square. So we will get the required area. Area of what is given? Shaded region in the question. Area of the shaded region is equal to simply area of the square, which we found out here, minus the unshaded part. 43 comes to 57 square centimeters. So this is the area of the unshaded part. Like this we can solve the problems in your textbook. There's one problem. I'll be giving you the hint. The next problem, you can easily solve it. See, this is the 4th one. The next one, you need to solve, children, because I'll be giving you some hint so that you can easily solve it. The problem says that, 5th one, find the area of the shaded region in the figure if ABCD is the square of side 7 centimeters. ABCD is the side with 7 centimeters and the shaded part given like this. So this part we are asking. This shaded part. Also given that APD and BPC, this is P here, APD and BPC are the semicircles. Here use 22/7. So in this, what we do? First find the area of the square, then find the area of the two semicircles. If you subtract the area of the square, if you subtract the area of the semicircles from the area of the square, you get the shaded portion. So with this hint, you complete the second one, that is the 5th one. Now let's do the 6th problem. So in figure OACD is a quadrant of a circle O and radius 3.5. If OD is 2 centimeters, find the area of the shaded region. Use pi value as 22/7. This is the shaded region. We need to find the area of this shaded part. Given the quadrant. Quadrant is nothing but it is the 1/4 part of a circle. We know the semicircles. This is 1/4 part of the semicircle. Also, it is a sector. It's a part of a circle taken from the center. So, it's a sector. So, to find the area of this shaded part, we will find the area of the sector first. Then, we will subtract the area of the triangle from the sector. We will get the area of this part. So, area of shaded region is equal to area of sector. What is the sector? 0 OACB. Area of the sector OACB minus the area of triangle DOB. Okay. So, we know the area of the sector. This is given as quadrant. Quadrant means 1/4 of a circle. So, 1/4 of 360. This angle is 90 degrees. So, the complete angle is 360. 1/4 is 90 degrees. So, the angle of the sector is 90. So, let me first write the area formula. X degrees by 360 into pi r square minus what is the area of a triangle? Half. into base into height. Now we'll substitute the values. X is our 90 degrees by 360 into pi value given as 22 by 7 into R value is 3.5 square. So 3.5 minus, so let us keep this in one bracket, minus half into base is 3.5 into height is 2 centimeters. So we'll solve this. This comes to 1/4. 22 by 7, 3.5 to 3.5. See, 1 by 4, 22 by 7, 3.5, 3.5 comes to 12.25. Also, twice, minus, you can cancel both two, so just 3.5. Here, we got 11 into divided by 7 minus 3.5. This comes to 9.625. If you solve, minus 3.5. So 9 minus 3, you get 6.125 square centimeters. So this is the area of the shaded region. We have found out from the area of the sector minus the area of the triangle. So area of the shaded region equal to 6.125 centimeter square. So let's see one more problem. If AB and CD respectively are arcs of two concentric circles, AB and CD, of radii 21 centimeters and 7 centimeters with center O, see the figure. If angle AOB is 30 degrees, this is 30 degrees AOB, find the area of the shaded region. Use the value of pi as 22 by 7. See this figure. This is in the form of a sector. It has been removed from concentric circles. You know concentric circles? The circles having the same center. From this, a part is removed, cut. So this is the part. So here it is asked the area of the shaded part. So we'll find the area of the big sector. Yesterday we have learned the big sector means a major sector, OAB, and area of the small sector, that is OCD. We will subtract both of them, we will get the area of the shaded part. Area of shaded region Since these two are concentric circles, they have given the radius of the bigger circle is 21, the radius of the smaller circle is 7 centimeters. So area of the shaded region is area of major sector. What's the major sector? OAB minus area of minor sector, that is O, C and D. So area of the sector is x by 360 into pi r square. So the r values will change. For the major sector, r value is 21. For the minor sector, r value is 7. So, and the angle is common for both because they are concentric circles having the same center. So the angle here is common to both the sectors. So x by 360 here, the major sector x is 30 degrees by 360 into 22 by 7 R is 21 to 21. So this is the major sector area minus area of the minor sector. That is again 30 degrees by 360 into 22 by 7 into 7 into 7. So we'll take common 30 by 360 and this. Or else we can also do, okay, we'll take this as common. 30 by 360 into the pi value I'll take common. Here 21 square minus 7 square. So you can simplify it and get the answer. 360 into 22 by 7. 21 square is 441 minus 49. So we can also cancel this also. Thrice like once. 12. So 1 by 12 into 22 by 7. Again 441 minus 49 is 392. So this bracket is again multiplication. If you simplify it, so if you cancel it and simplify, you'll get 102.66. It is recurring decimal in 6 bar. The area we got simply by subtracting the major sector and the minor sector. So like this, there is one more problem. Let's do the next problem. Calculate the area of the designed region in figure. See this figure? Common between the two quadrants of the circle of radius 10 centimeters each. Use the value of pi as 3.14. So we need to find the area of this shaded part. Here given the square with 10 centimeters and the quadrant. So let's name this as E and F. Okay. So the quadrant A, D, E, B and the quadrant C, D, F and B. The quadrants are nothing but 1/4 part of the circle. They are the sectors. So area of shaded region, we'll find out. Shaded region or the design part is equal to the area of the square minus area of the sectors. Area of square minus area of two quadrants or the two sectors. See the design part in both the quadrants, it will be repeated. If I find the area of one quadrant, I'll get the design part once, and again if I find the area of the other quadrant, again the design part is repeated. So the design part or the shaded part is repeated again. So if you find the area of two quadrants and if you minus from the area of the square, then you'll get only the shaded part. So area of the square, side into side, that is 10 into 10 minus area of the two quadrants. Now one quadrant is the sector, so 2 into the sector. Here with the center A, here with the center C. So center A 90, C is also 90. 90 into 360 into the pi value given as 3.14 r square, 10 into 10. So here, something. First we have to find the area of the two quadrants, then we will subtract the area of the square because the part is repeated here. So 2 into 90 by 360 into 3.14 into 10 minus the area of the square, that is 100. 10 into 10, 100. So if you do the calculation here, you will be getting a value of 1022. Let's calculate 9 ones, 9 fours, 2 ones, 2 twice, 2 ones, 2 fives. So we'll be getting by 7 minus 100. Here 1100 by 7 minus 100. If you take the LCM, 1100 minus 700 by 7 comes up to 400 by 7. So this is the area. So you simplify it, you will get the area into square centimeters. So what I did here is that since the design part has been repeated in both the quadrants, so I am minusing it with the area of the two quadrants. Area of the two quadrants minus the area of the square. So that we will get 400 by 7. You simplify it and make it into the decimal part. So likewise, we will complete this. We have completed this chapter, tangents and secants. So revise well all the exercises, and we'll look into our next chapter,